Hello, this is Sadbir. The topic of our discussion in this video is to find the local maximum and local minimum value of a function. Let's look what is a local maximum or local minimum of a function is actually. Here we have I have a graph of a function where you can find a couple of local min and local max. So local min of a function is a point where the function switch from increasing to decreasing or increasing to decreasing. So as we can see, the local min is a point if on the left side of that point is function is a decreasing, and on the right side of that point, the function start increasing. Contrary to that, the local maximum is the function is increasing on the left and the function is decreasing on the right side of it. This is a very important for business and in industry to find the local max and local mins of our business cycles, because this will tell us that when our profit was max and when the profit is min, and it determine the business cycles. Let's see how to find these local max and min. So we will use the derivatives of the function to find the local max and local min. As we can see in the previous video, we have saw that in the previous video, then the function is decreasing, the derivative of the function is a negative, and when the function is increasing, derivative of the function is positive. So if you have a local minimum, then the derivative of the function will change the sign from negative to positive around that point. So local min will be a point where the function will, the derivative of the function change sign from negative to positive. And similarly, or contrary to that, on the maximum, on the local max, the derivative will change sign from positive to negative. And then exactly at that point, we can see that the derivative of the function will be 0. So the derivative is positive and derivative of the function is a negative when we move from left to right on the local max. On the contrary, on the local min, the derivative is a negative to positive. It's change sign from negative to positive when we move from left to right. Let's practice this concept on a example. So I have here an example which is a polynomial function 2x to the power 3 plus 3x square minus 12x plus 1. We will find the local max and local min of this function using the derivative of the function. So I will solve this problem in a 3 simple step. In step number 1, we will calculate the derivative of the function f prime of x. In the step number 2, we calculate the critical value of this function, or I will set the derivative is equal to 0. And in the step number 3, I will test these critical value, which we will call the first order derivative. First derivative test. I will check these critical value for local max and local min. So what is the derivative of the function? It is a 6x square plus 6x minus 12. And I can simplify this derivative a little bit. I can pull out 6 because 6 is a common factor. This is x square plus x minus 2. So now this is the derivative of my function. I can also factor this polynomial, the second order polynomial. The factor will give me x minus 1, x plus 2. And if I set this derivative is equal to 0, what that means is I will plug 6x minus 1, x plus 2 here, and that set is equal to 0, and find the value of x. My x will be 1 and negative 2. So these are the two values where my derivative of the function is 0. So I will test these two values for local max and local min. Here is a -2 and here is a -1. So I will pick some test point on the left and right side of 1 and similarly left and right side of -2. I can pick here, let's suppose -3. I can pick here 0 and I can pick here 2. I will do this line test on the derivative of the function, which is f prime of x, which is a 6 x minus 1 x plus 2. If I plug -3 in the derivative, so here I have a -3, -1, so this gives me a negative number. And if I plug -3 here, it will be a -3 plus 2, which also will be a negative number. So negatives, they will give me a positive here. So the sign of my derivative at -3 is positive. If I plug 0, this will become positive, and this is still negative, and this is always positive number. So this gives me a negative sign here. But if I plug 2 here, so in that case, this will be a positive, and this will also become a positive in that situation. So I will have a positive. So after plugging these test point into my derivative, I find out that on the left side of -2, my derivative is positive. On the right side, it is negative, and on the right side of 1, it is a positive. So the sign of the derivative is changing from positive to negative around x is equal to 2. So this will be a local max will be x is equal to -2, and our local min will be x is equal to 1. X is equal to 1. Okay, let's move to the next problem. Here I have a quiz problem for you to practice. So pause the video for 1 minute or two. And once you have your answer, you can submit your answer in the link above uh, to compare your answer with the other pupils who have taken this quiz. And this is my next example, example number 2, where our function is x to the power 4 minus 5x. So again, I will do this problem in 3 steps. In step number 1, we will calculate the derivative of the function. So f prime of x. Since it is a polynomial function, I will use the power rule to calculate the derivative of this function. And after calculating the derivative, I will also simplify the derivative of the function by pulling the common factor. Here x to the power 3 is a common factor. It's gonna be a 4 minus 5x. And in step number 2, I will set this derivative is equal to 0 to find the critical value. So x cubed 4 minus 5x is equal to 0 gives me x is equal to 0 and x is equal to 4/5. So these are my two critical value. In step number 3, I will do the line test. So what are my point? My point is 0 and 4/5. Now it's a time to choose some test point. You can pick any point here on this side of the interval or on this side. So since I'm doing this test on the derivative of the function, so I will write down what is the derivative of the function. Here is x cubed, and this is a 4 minus 5x. And when I plug these point into the derivative, let's choose a point here, -1. I can choose 4/5 is slightly less than 1, so I can choose 1 here, and then I can choose 1/2 here. If I plug -1 here, this will be a negative number. If I plug -1 here, this will be a positive number. So negative and positive gives me negative number here. If I plug 1/2 here, so this will be a positive now because 1/2 is a positive, and this will be also positive because I'm plugging 1/2. This will be a 5/2, which is a less than 4. So that gives me a positive number here. If I plug 1 into the derivative of the function, this will be a positive. And if I plug 1 here now, this will be a negative. So this gives me a negative. So I can see the sign is changing from negative to positive, negative to positive. So this point is local minima, and this point is local maxima of the function. Also, you can calculate the minimum value. So what will be the minimum value or the maximum value? So the local minimum. So local minimum is the y value of the function when you plug the x value. So if I plug 0 in the function, so the minimum value of the function will be 0. And the local maximum will be when you plug 4/5 into your function. So this will be 4/5 to the power 4 minus 4/5 to the power 5. You can use the calculator to simplify this expression. Okay, so as also we can verify answer by plotting the graph of the function. You can see this is my minimum value and local minimum value, and that's my local maximum value of the function. I have one more problem here. In this problem, we have the exponential function. So we again calculate the derivative, the local max or local minimum of these functions using the three-step method. In step number 1, I will calculate the derivative of this function, which will be really interesting here because we have the exponential function e to the power -x. So derivative of the function will be using the product rule because this is the product of two functions. So x square time e raised to power -x plus x square times derivative dy by dx of e raised to power -x. So derivative of x square is a 2x, and e to the power -x is as it is, and x square is as it is, and the derivative of e to the power -x is e to the power -x times the derivative of -x, which is a -1. So if you remember, derivative of e to the power u is a e to the power u times u prime, and that's your u is here. So now I will simplify this expression by pulling out the common factor. E to the power -x is a common factor, so I will pull out. This is a 2x minus x square. And then I notice that x is also a common, so I will pull out that. So this is the simplified form of my derivative. In step number 2, I will set this derivative is equal to 0. So x e raised to power -x, 2 minus x is equal to 0. And I will find the critical value. My critical value will be 0 and 2, because this number cannot be, this number is always strictly positive. So this cannot be 0. So the only critical value will be coming from this factor and that factor. In step number 3, we will use the line test on the derivative of the function. So I will write f prime of x, which is a x e raised to power minus x, 2 minus x, and I will draw that line, plot the critical value on the line, 0 and 2, and pick some test point on the line. -1 and weak 1 and 3 here. If I plug -1, so this will be a negative number here. If I plug -1, this will be a positive number here. So here will give you a negative number. If I plug 1 here, that will be a positive number. This is always a positive. And if I plug 1 here, that will be a negative number. So sorry, this will be a positive number. So this gives me a positive sign. And if I plug 3, this will be a positive number, this will be a positive number, but this time this will be a negative number, so this will be a 2. So therefore, our local min will be this point. This is a local min, and this point is a local max. We can calculate the local max and local min value. So which point is a local min? So local min occur at x is equal to 0, and local max occur at x is equal to 2. You can calculate the local minimum value and maximum value by plugging these values into the original function. Here is the graph of this function. You can see this is the local min and that is the local max of the function. Now this problem, we have a quotient of two functions, x plus 1 square divided by x times x minus 2. It will be challenging to calculate the derivative of this function and finding the critical values. I will show you the derivative, how to calculate the derivative function, but you can also watch the video on the quotient rule to go into the more detail of this method. So here in step number 1, we calculate the derivative of the function by using the quotient rule. So f prime of x. So here I will do my calculation, x square, and then you have x minus 2. Derivative of the top is a 2x plus 1 to the power 1. And the derivative of the bottom, you can use the product rule here to calculate the derivative of this term, which will be 1 times x minus 2 plus x times 1. So therefore, this is a 2x minus 2 and 2x minus 1. So the derivative of the bottom term is x minus 2 times x minus 1. And now once we have the derivative of the bottom and the top, we will do this, use this method to memorize this derivative, low d high, high d low, which we learn in that chapter. So I will write down the chain rule, the quotient rule here. So low function x minus 2 is a low function, multiply to high, which is a 2x plus 1. Then I put a negative sign and the high function x plus 1 square multiplied to 2 times x minus 1 divide by low square x minus 2 square of that. Now let's see common factor. I see 2 is common and I also see x minus x plus 1 is common. So I will pull out the common factor. So I will left with the x minus 2, and that's the minus x plus 1 and x minus 1. And parentheses here, divide by x square, x minus 2 square. So if I FOIL this term out here, this term, and also FOIL them, negative sign, I have to be careful with this. So this is going to be 2x plus 1 This will be x square minus 2x. This is going to be x square. This is going to be x square minus 1 square. So x square plus 1 square. And this will be x square, x minus 2, the square of that term. This cancel out with this. This will be a 2x plus 1 and 1 minus 2x divided by x square, x minus 2 square. So this is the derivative of this functions, and also this is the simplest form of the derivative. So to find the critical values, I will take the top and bottom both is equal to 0. So I will put that top term is equal to 0, which gave me 2 critical value from the top, and also I will give the bottom is equal to 0 to find these critical value. So I have these 4 critical value. 2 is coming from the top, 2 is coming from the bottom. Also note that this critical value 0 and 2 are not in the domain of the function. So next we did the line test. So we choose some point on the left and right on these critical values and find the sign of the derivative of the function. So what I found is the derivative on the left of -1 is negative, and on the right is positive, and on 0 is a positive, on 1/2, then it is right on 0 is a positive, and the right of 0 is again negative. So the derivative is changing sign, positive, negative to positive, then positive, positive, then positive to negative, and negative, negative. So this conclude that this point and this point is the only where the will achieve the max or minimum value, local max or local minimum value. Since 0 is the direct sign of the derivative is not changing around 0 and 2, so these points are not local max or local min, so they are neither. Okay, this is all I have for in this video in terms of the example, as far as concern of examples. Here I have one more quiz problems for you to practice your skill on this skill of this calculating the maximum or minimum value of this function. Please pause the video for 1 or 2 minutes, and once you have your answer, you can submit your answer in the link above to check your answer with the other people who are taking this quiz. This is all I have for now. Thank you very much for watching my video. Subscribe my channels and hit the like button if you like my video. And see you in the next video. Bye bye for now.